This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 1 of Week 2, Fluid Statics, Hydrostatic Pressure, Manometer Balances, Forces on Submerged Surfaces, and Buoyancy. 2 Exam Patterns. 1 Root Idea. First, hydrostatic pressure, depth, manometers, pressure on a submerged surface. Second, buoyant force. Both follow one law. In a static fluid, pressure rises linearly with depth. 5 properties on every fluid's problem. Rho, mass density. Mu, dynamic viscosity. Nu, kinematic viscosity, mu over rho. Gamma, specific weight, rho times g. And specific gravity, density relative to water. Mercury sits at 13.6. The property tables live in Handbook, Chapter 1. Hydrostatic pressure, P equals P0 plus rho GH. P0 is the reference pressure, H the depth below it. In IP units, replace rho G with gamma. The key insight: pressure depends only on depth, not horizontal position or container shape. Same elevation in a connected static fluid, same pressure. 5 rules to walk any manometer. Start where you know the pressure. Open to atmosphere is 0 gauge. Down a column, add rho GH. Up, subtract. A horizontal leg at the same elevation costs nothing. Use each leg's actual density. Mercury is not water. Walk leg by leg to the unknown. Variable table for the manometer walk. Every row is 1 leg. Reference pressure at the top. 0 gauge if open. A density for each fluid. Heights from the diagram. Plus rho GH going down, minus going up. The sum gives the unknown vessel pressure. List every leg before you start algebra. 2 more formulas. First, pressure at any point on a submerged surface. P equals P0 plus rho GH, where h is the vertical distance from the free surface to the point. For an inclined surface, convert slant to vertical via y equals h over sine theta. Second, buoyant force equals gamma times the displaced volume. Fully submerged, that's the full body volume. Exam-style manometer problem. U-tube with mercury in the bend. Left leg, water, open to atmosphere. A 0.4 meter column above the mercury. Right leg, oil, at 850. A 0.25 meter column up to the vessel tap. Mercury on the right sits 0.1 lower than on the left. Find the vessel gauge pressure. Walk the legs from the open left surface, 0 gauge. Down through water, add rho water G times 0.4. Down through mercury, add rho mercury G times 0.1. Up through oil to the tap. Subtract rho oil G times 0.25. 3 terms, 1 balance. Collect the 3 terms, multiply by G, and the vessel pressure lands at about 15.1 kilopascal gauge. Notice the mercury carries nearly 90% of the total from just a 0.1 meter deflection. That's the lesson of mercury manometers. Answer: about 15.2 kilopascal gauge. Units check. Density times G times height gives pascals. We set the open leg to 0, so this is gauge. Add atmospheric only if the question asks for absolute. Pressure on a point walkthrough. Inclined gate at 30 degrees. Point P 5 meters down the slant. Convert to vertical. H equals y sine theta, 2.5 meters. Gauge pressure is then rho water GH, about 24.5 kilopascals. For absolute, add atmospheric, about 125.8. Buoyancy walkthrough. Sphere 1.5 feet in diameter, fully submerged in fresh water. Volume is pi times d cubed over 6. Buoyancy force equals specific weight times displaced volume, about 110 pounds force. The material never enters, only displaced volume and the fluid's specific weight matter. 5 traps. 1. Gauge versus absolute. Most problems want gauge. 2. Slant distance versus vertical depth. Convert via h equals y sine theta first. 3. Keep manometer density straight. Mercury is not water. 4. Rho versus gamma. They differ by G. Don't mix IP and SI. 5. Buoyancy uses displaced volume, not full body volume. For a partially submerged body, only the wetted volume counts. 5 things for the exam. Pressure equals P0 plus rho GH. Manometer rule, down adds, up subtracts. For any submerged point, P equals P0 plus rho GH, slant to vertical via H equals Y sine theta. Buoyancy is gamma times displaced volume. And know the 5 properties: rho, mu, nu, gamma, specific gravity. Onward to topic 2, continuity and Bernoulli.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.